Hello dear students. In this video I will explain about water of crystallization. So by the name you can understand students, water is present inside some compound, some chemical compound in the form of you can say that crystalline state. Crystalline state means you can it's not in the liquid state, okay, in solid crystalline form. Suppose if I give you an example, blue vitriol, okay, which is present in the market, means available in the market. In Bengali it is known as tute for color purpose, okay, blue crystallized substance. That's why I'm saying first that it is available in the market, that copper sulfate, okay, and it contains 5 molecule of water, okay, that is the formula of that compound, okay, CuSO4 with 5H2O, one dot will be there, okay, here. So that copper sulfate is called blue vitriol, which is available, we widely used in our daily life. Daily life means mm, in it is available, okay, in the market. Mm. So that is a good example of water of crystallization. Okay, so if you see it, it is a blue crystalline substance. Crystalline means proper shape. Okay, crystalline, amorphous is there, different to different state of the compound. Okay, amorphous means no definite shape, but crystalline means it has a definite shape. In carbon and its compounds chapter, you will learn properly about crystalline structure. Okay, so that is the thing. So their crystal shape neat, they keep the take the water molecule and they are in a proper shape, solid shape, okay, and water molecule inside it in the solid form, that is called water of crystallization. So just go with a proper definition. You can read here that water of crystallization or water of hydration or crystallization water, that this is known as also water of hydration, because if you give a heat, this water will evaporate, okay. So that is the water that present inside some chemical compound which are in crystalline state. It is the fixed amount of water that makes the crystal, and and is also responsible for the shape as well as color of the crystal. Okay, so whatever the shape and color of the crystal, that water molecule is responsible also for it. Okay, that's why if you give little bit temperature, that water molecule evaporate, so color also change, shape also change of that molecule. Okay, so water is often necessary for the formation of crystal. Classically, water of crystallization refers to the water that is formed in the crystalline framework of a chemical compound, generally a salt, which is not directly bounded to the metal cation. Okay, it is not directly metal to the atom, bind to the bonded, not bonded with the metal cation, but it is present. Okay, so here the water of crystallization is attached loosely within the crystal and is represented with a dot next to the chemical formula of the compound forming the crystal. Crystals contain salts and water combined in definite proportion, and when heated the water is lost. I already told you. So students, here copper sulfate form blue crystal. Okay, very easy example, means this compound you can buy from the market and you can experimentally you can see it, okay, in your home. Okay, others are not so much present. Okay, so when it is heated, it loses 5 molecule water and converted into a white powder of copper sulfate. Students, these are important because examples, and suppose the question will come, what happened when copper sulfate heated. Okay, so it will lost its water of crystallization and converted into a white powder. Similarly, some other example, iron sulfate 7H2O. Okay, they are having some common name also. In class 9 you will learn much more about these things. Is light green in color, on heating loses its water and form white powder, FeSO4. Other examples are sodium carbonate 10H2O, which is called washing soda, and sodium sulfate Na2SO4 10H2O. These are also other two examples. Okay, so their chemical name you can read like this: sodium sulfate decahydrate. Okay, decahydrate, that is sodium carbonate, that is also decahydrate. Okay, 7 means heptahydrate. Okay, ferrous sulfate heptahydrate, copper sulfate pentahydrate. Okay, these are their chemical name. It has written over here. So students, this is the thing. And now the salts containing water of crystallization is known as hydrated salt. On heating, they lose the water of crystallization and they are called anhydrous salt. Okay, when this crystallized water will evaporate, then the means the residue that is you called, or the remaining part, remaining that powder, you can say anhydrous salt. Okay, some substance that absorb moisture from air but not enough to form solution is known as hygroscopic substance. Okay, so definition you must remember: what is hydrated salt, okay, what is anhydrous salt, what is hygroscopic substance. Okay, once again you just read: some substance that absorb moisture from air but not enough to form solution. So here is the three question thing: one is hygroscopic, another is deliquescence. Okay, I am showing you here the next page. You can see deliquescence. Okay, another one is efflorescence. Okay, so these three substance, three definition, how to remember, very easy. I am saying that one substance, okay, one substance when exposed to air, some substance, okay, when exposed means in open air, absorb water molecule, and in the they will absorb the water molecule and they will dissolve in it. That is called totally they will dissolve. If they will dissolve, then they are called deliquescence. Okay, so the I think you definition you understand that so- some substance when exposed to the air, they will absorb water molecule from the air. Okay, they absorb water molecule from the air and they will ultimately dissolve in it. Okay, so means that substance we can't keep in open air. They will totally absorb water and they will form liquid shape. Their totally state will change. So they are called deliquescent. And students, if some substance also there which can absorb, 1 minute, which can absorb water molecule but not dissolve in it, they are called hygroscopic. Okay, means the second step you can say, one is sufficient amount of water molecule they will absorb and they will dissolve, they are called deliquescent. Example: sodium hydroxide, solid sodium hydroxide, calcium chloride, okay, and hexahydrate, okay, ferric chloride, potassium hydroxide, magnesium chloride. Okay, these are the example of deliquescent substance. Similarly, substance, okay, the phenomenon of absorbing moisture from air but not enough to change the state, means little bit water they will absorb. They are called hygroscopic substance, and that phenomenon is called hygroscopy. Okay, so the phenomenon is called deliquescence, and the substance is called deliquescent substance. Okay, mm, so here, since these substances can absorb water from air, they can be used as drying agent for gases. Because if a gas is production of gas, if some gas, suppose hydrogen, production of hydrogen, in their little bit water molecule is present, okay, as the byproduct. So that water molecule will absorb. If there is hygroscopic substance will there, it will be good to absorb water molecule, because it has the tendency to absorb water molecule. So hydrogen, mm, pure hydrogen gas we can collect. Okay, so that's why their purpose, they are used as drying agent for gases. Okay, it is because of that silica gel packet kept in the bottle to keep them dry. If you buy new bottles in market, you can see small piece of paper and inside them white crystalline some uh, product is there. Okay, inside the bottle you can see. If you buy some new bottles, okay, quite expensive, then you can see that inside the new shoe also, that types of small packet of white crystalline things are there. They are called silica gel. Okay, silica gel has the power to absorb water molecule and keep it dry inside that bottle or the shoe. Now come to the efflorescent. Efflorescent is totally reverse, means some compound when you keep in open air, they will totally remove their water molecule, their combined water molecule they will release. Okay, they lose. Suppose with an example, you can see sodium sulfate 10H2O. They lose all its water molecule when exposed to the air. So that is known as the efflorescent substance, and this phenomenon is called efflorescence. Okay, so students, one example, definition, phenomenon, and that examples are very important. Sometimes from the examples question used to come. So up to this portion in today's lecture. Next lecture I will talk about reactivity of the metal.